This is a tutorial video for MUSC 4400 covering the combining of sine tones and acoustical beating. In the week 1 PD examples, you get down to example 7 and example 7a, and they show the principles of acoustical beating. If I open up example 7, this is really close to what you need to do for your homework for week 1. You have two oscillators, each creating a sine tone being added together. When you have two sine tones being added together, much like when you have, if you're tuning two strings on a guitar, when they come close to each other in frequency, you start to hear this wavering in the amplitude of the resulting tone. And so if we look over at 7a, this shows what happens when you combine sine tones in this manner. As we know, sound waves are pressure waves in the air, and when you're adding two waves together, you're literally just looking at the peak of each wave versus the trough and peak of the other wave that you're adding together, and then they are added in time. So if you were to see two waves in the ocean and one passes underneath the other in that moment when that wave passes beneath the first, the two waves combine into a higher wave, or a wave of greater amplitude. So in this case, I have two sine tones, each set to 220 hertz. Make sure my DSP is turned on, turn on my graphing, and you can see we're graphing this sine tone right here, this sine tone right here. They both look like a single wave with an amplitude of, from -1 to 1. But then I just add those two signals together with a single addition tilde object, and then graph the result of the combined sine tones, and lo and behold, our sine tone is twice as loud. Now, if I were to set the phase of these sine tones perfectly out of phase by clicking this bang, now they add up to 0 because the peak of one of the sine tones lines up with the trough of the other. And it's simple addition, +1 plus -1 equals 0. The half of the trough, 0.5 plus -0.5 equals 0. And then right when they're both at the 0 point, that also equals 0 when they're added together, and so forth and so on. But if I set them, now I'm just going to reset the phase of one of them, and it'll be at an arbitrary point in time. So now I got it almost perfectly, which is kind of shocking. Let's do it again. Yeah, so now I'm kind of like guessing, and now they're out of phase with one another, but they're not perfectly out of phase. So that means the sum is going to be somewhere between 0 and 2, but you have to know the phase to perfectly predict that. So what happens when I change, I'll put them both perfectly in phase again. What happens when I change one oscillator's frequency by 1 hertz, you can see that this oscillator it's still a sine wave with an amplitude of between -1 and 1, but its frequency is slightly higher, which means its wavelength is slightly smaller. So its relationship to the other sine wave is sort of phasing when it comes down to the amplitudes of the two sine waves combining. So when the peak lines up with the peak of the other sine wave, that sums to 2. But when the peak lines up with a trough of the sine wave, it sums to 0. And the result is this sine wave that has a changing amplitude with a frequency of that amplitude change at 1 hertz. The difference between the two sine waves gives us that change in amplitude's frequency. So we'll listen to that. And so if I've got this set to 20.5, now we have a difference of half of a hertz, so we get a difference every 2 seconds. If this is set to 225, now our tremolo, resulting tremolo, is 5 times per second. So if you're trying to get, for your homework, a difference in acoustical beating, or an acoustical beating speed of 10 hertz, what do you think the difference between those two values must be? Okay, so there's a second aspect to the homework, and that is to use a third oscillator to create an additional tremolo on top. So if I were to set this to 1, now we hear a cycle of amplitude against this cycle of amplitude, and I'll speed this way up just to, that's not sped up. There. So now you can kind of hear the peak of amplitude, top, 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 top. And you can see that it's peaking both when the output of this oscillator is at 1 and when it's at -1. So our oscillator is going between 1 and -1, once per second. So we're getting 2 amplitude peaks per cycle. If I switch to 2, now we're getting 4. If I switch to 0.5, we're getting how many peaks per second. So that's sort of your homework. Figure out how to get 4 peaks per cycle, or rather 1 peak per 4 seconds, or 15 cycles per minute.